Hi everyone, it's me, Carolyn, and I am going to be doing a normal curve example, one that deals with percentiles and rankings, so to speak, which is a slightly different terminology than using what is the probability of. However, they are very closely related. So we're going to do one in terms of an exam, because when we talk about exams or people's weights or things like that, we do talk about the percentile. So you could have just said, a newborn, a 5-year-old child's weight is normally distributed with a mean of 83 and a standard deviation of 5.8. I make these numbers up, so these actually are not real life problems, but so don't take a lot of stock in the example itself. Just kind of look at the process of these problems. So let's say we do have a certain exam. It is normally distributed with a mean of 83, standard deviation of 5.8. And we have a student, Tony, who scored a 98 on this exam. And we want to know what percentile Tony is in. Okay, so first thing I'm going to do is I am going to use a picture to kind of draw what's going on. So we have normally distributed. Again, means we've got our bell curve. Okay, in the bell curve, we know that the center of that curve is 83. We could use that 5.8 to set up our 95 or 68, 95, 99.7 tick marks if you wanted to. But I'm not going to, because I want to find the percentile of the 98. So she's getting, or they are getting a 98 on this exam. And now we have to remember what the word percentile means. The word percentile, maybe remind us, percentile is the percent that scored at or below. Okay, so we want to know what percentage of the students scored here or below. Now, percentage is kind of the same idea as a probability, but looking at it with just a different term. So I can find the probability that someone scored below the 98 or at or below the 98, and that would be the same idea, same exact process. So a lot of times you're doing the same calculations over and over and over again, but putting different terminology on them. Percentile, percentage, proportion, probability, all of those pieces are asking the same kind of ideas. Okay, so don't get confused with the terminology. Just remember that percentile is that point all the way down from there and below. Okay, I am going to do this one two ways. I'm going to do this one using a table so we can review how we kind of do that. And then I'm going to go and use StatCrunch to save us some time. And then I'll do a couple more as well, and I'll do those using StatCrunch. So to do this using a table, I would first have to standardize that score. And a lot of times when you take ACTs or SATs or all these other standardized exams, they will give you a standardized score. And that standardized score is the actual Z-score. And if you can remember, the formula for our Z-score is your data value minus your mean divided by your standard deviation. So we're going to take that 98 minus the 83 all over my 5.8. And so now I'm getting my calculator out. I'm taking 98 minus 83, getting that value, dividing it by 5.8, and I get 2.5862, and there's a bunch more decimals. Okay. And now this is where things are going to become a little different than what we would get using StatCrunch or some other technology, because we do need to do some rounding. Okay, so if I'm using the table, My table only goes to 2 digits, which means I need to round this to 2.59. So 2.59, so I'm looking on here is my 2.5, and my 9 is 0.9952. So from the table, we got 0.9952, which if I turn that into a percentage, 99.5 or 5th percentile. Or they scored better than 99.5% or right in that 99.5 percentile. Okay, I'm going to go to StatCrunch, so give me a moment while I switch screens. Takes a while to do this. And so forth. This is still set up for my old example from my previous piece. So we have an 83 is my mean. My standard deviation of 5.8. And we want to know the probability of scoring below a 98. And we're going to compute. So 0.9951. There we are, which is pretty close to what I had. A little bit different in the decimals or so, and it can be a little bit more different if we had been closer to the middle. But still we see that 99.5th percentile. All right. So again, to get to this screen, we would have gone into Stat, under Calculators, over to the normal. Clicking this one brings up this screen. Change your mean, change your standard deviation. You can put in those tick marks, that empirical rule tick marks, if that helps you understand things better. And we can go and do it this way. All right. I'm going to go back to my other screen so we can get our next question. I'm going to use the same test piece, but we're going to do a different question on this. So we still have that same test. So we had that certain exams normally distributed with a mean of 83, standard deviation of 5.8. And here's the next piece of this question. We have a student who scores, I should probably put scores, in the top 5%, gets the opportunity to join in on a pizza party. So in other words, this is an instructor's way of kind of saying, okay, here's our standardized test. Anyone that can get in the top 5%. So that would mean the 95th percentile or better. Okay, so that Tony, who had that 99.5, would have made it. But what we want to know is what score must they earn to get into that pizza party? All right, so I'm going to draw a picture so we can see what's going on. I like to draw lots of pictures. I don't know if that helps you as a student, but I know they always helped me make connections. Here's my 83. We want the top 5%. So top is up here. And percentages are always kind of in that area. So here's our 5% that we're looking for. Okay, 5% as a decimal is 0.05. We're going to need to remember that. And we are looking for the score, so that this area above it gives me 5%. Okay. And I am going to go and use StatCrunch to figure this out for me. So here we go. Again, I'm going to stop sharing this screen. I wish I could have dual share, but we haven't got that technology yet. So I'm sure that's coming. But we'll go back to our StatCrunch. Okay. Still has my 83 in here, still have my standard deviation of 5.8. X being less than, now 98, we're looking for a score this time, right? And we want our score, and we want to be bigger than that score. So I'm going to change this first of all. I'm going to get rid of this 98 because that's the part I don't know. So I'm looking for x bigger than some value to give me 0.05. So I'm looking for that top percent. So here's that 0.05 in the shaded region. That's this piece. And the score that they need to get is roughly a 92.54. Okay, so that's how we would do that using StatCrunch. I am going to go through back to this one and do it as if we didn't have StatCrunch or technology that would do it for us. Because not all stat courses have StatCrunch. And if you're watching this video outside of that type of course, you still may need to know how to do that. So I'm going to stop sharing StatCrunch, go back to this example, and show you how in the world would I get this 92.54 that StatCrunch gave us without knowing having the technology. So I'm going to be using my table. Okay, so I'm going to be using my table. Now the table, again, remember, it gives you the bottom area. So if this is 5%, this area here is 95. So what I need to do is I'm going to find the z-score for that 95%. Or other books may be looking for that z.05. And that means I'm going to be looking for where is that 5% in the upper tail or the 95% in the lower tail. So I'm going to be looking in here. That's my percentages, my proportions, my probabilities to be 95%, so 0.95. And I'm following, here's a 94, getting a little bigger. There's a 9495. Here's a 9505. So my z-score is going to be smack dab between those because those are straddling it exactly. And that's 1.64, and then halfway would be 5. So 1.645 is the z-score. Now, z-scores, we have to now find, this wasn't a z, this is a test score. So I have to kind of unstandardize. So we're going to remember that z is equal to our x minus our mean all over the standard deviation. Our z is 1.645. X is what we're looking for, minus our 83, all over that 5.8. And now what I have to do is solve a little algebra. First thing I'm going to do is multiply both sides by 5.8. So I have 1.645 and multiply by 5.8, and I get 9.541. That is my x minus 83. And now to solve this one, I'm going to add 83 to both sides. So adding my 83, I find that x is 92.54. And there is a 1 on top of that as well. But you'll notice we got the same answer as StatCrunch did. StatCrunch took a millisecond, but we can still get there using a table by unstandardizing those values. We do have to go into the table and find our z that is represented in our picture, but you guys can do that. I'm confident that you can do that. Okay, let's do another one just for fun. And we will do this one again both ways, those of you that have StatCrunch and those of you that don't. But let's just say we want, again, still the same example, and we want to find the score that represents that 8th percentile. All right, I'm going to draw a picture. Okay, and I might do this one longhand first, and then we'll use StatCrunch to verify this. So here's my 83. Okay, and we're looking for the 8th percentile. So the first thing you kind of have to know is where in the picture this would fall. Now, 1/8 is not a very large percentile. I will remind us that the 83 is smack dab in the middle. So that is like our 50th percentile. So that means we're going to be over here somewhere. Okay, so if we were finding the 75th percentile, we would be up here somewhere. All right, but our 8th percentile, this is our 8% or our 0.08. So first thing I'm going to do is if I'm doing this one the long way, I need to kind of get the z-score because I can't go right to the score without technology. So, but I can use the table to find a z-score to represent that. So our z, which would represent actually 0.92, because we always go upper for the alpha. And you'll notice that later for that as to y, that comes later. Again, we can find that 0.08. And since we are below the mean, we're also going to be on the negative side. Above the mean will be positives, below the mean will be negative, and we're looking for 0.08. So, oops, negatives here. 0.08. Here, 0.079, 0.0808. This one's just a hair closer. Okay, so I'm at a negative 1.41. That one is just a little bit closer than this one. So my z is going to be a negative 1.41. And now I need to find this is a z, we want to find the actual score. So that means I'm going to take that negative 1.41, I'm going to set it equal to x minus my mean all over the standard deviation. So x minus the 83 all over that 5.8. I sometimes refer to this process as being unstandardizing. So I'm going to multiply both sides by 5.8 first. Notice we will still have a negative in here. So this is a negative 8.178 x minus 83. So I multiplied by 5.8. And now I'm going to add 83 to this. And I get that x is a 74.822 is what I came up with. 74.822. Okay, let's make sure we can get that with StatCrunch as well. And that will kind of conclude this video. But we're going to stop sharing and we will go to StatCrunch. Yay! All right, so we're still at the 83 with the 5.8. I'm going to change this to less than. That's the nice thing about StatCrunch is it allows us to go to the left, it allows us to go to the right by this simple click of a button. Our table is always one direction. Okay, but we don't know what this guy is. I'm going to get rid of this. But we do want this to be 0.08. So we want our x's to be less than some score to be our 8%, which is 0.08. And we are going to compute. And there's that 74.85 that we came up with. The reason ours is a little different is because we did have to estimate. You'll notice there was quite a big difference between that negative 1.41 and the negative 1.40. So really it's somewhere in the middle between those two. StatCrunch is a little bit more accurate, but a lot of times you will just be rounding to the nearest score. So for example, a 75 would probably be the one that they would use. They'd round to the nearest whole digit, the whole score. And say you have to get at least a 75 to be in that 98th percentile, or maybe they'd round down to the 74. And that's where the arguments can start between statisticians. Do we round up? Do we round down? But my videos are kind of more, not the rounding issues, but just the process overall. So I'm going to end this video, stop sharing here for you. And I'm hoping that you guys are getting a good grasp of this normal curve, how it can be used to find probabilities, percentiles, how to find scores to that are the 15th percentile, the 75th percentile, all those kinds of questions. Hopefully those of you that are using StatCrunch, my clips to StatCrunch help you as well. So have a great afternoon or day or evening or whatever time it happens to be for you. And I will see you in my next video.